This is the second video for the blue review packet that you got in class on Tuesday. A question like number 7 is one that people definitely are still kind of struggling with. So I'm trying to come up with different ways to have you think about numbers. So we have real numbers, which is any number you can think of. There are imaginary numbers, but we haven't learned about those yet. Okay, so for right now, any number you can possibly think of is a real number. Within the real numbers, they're split into two categories. We have rational numbers and irrational numbers. Irrational numbers are things like pi, square root of 7. These are decimals that do not repeat or end. Rational numbers are positive or, whoops, that's not what I meant to do. They're positive or negative. They can be whole numbers, decimals. As long as the decimals repeat or end, and fractions. Underneath the rational numbers, there's a smaller set of numbers that we would call the integers. And integers are positive and negative whole numbers. So -2, -1, 0, 1, 2, and going on and on forever. There's a smaller set of the integers, which are called the natural numbers. Actually, I should say the whole numbers. And these are 0, 1, 2, 3. And then there's an even smaller set called the natural or the counting numbers. If any of you have little siblings, you know they typically don't start counting at 0. They start counting at 1, 2, 3, and those are your natural or counting numbers. So now let's go back and look at number 7. So they give me the function g of m. It's the amount of gasoline consumed by a car traveling m miles. An appropriate domain. Your domain is your input. So domain would represent miles. Okay, so how many miles does a car travel? So let's look at number 1, integers. Could a car travel -2 miles? Well, it doesn't say that it's going to be, we're looking backwards in time, so I don't think integers are going to work. Rational numbers include the integers. So if the integers aren't going to work, the rational numbers aren't going to work. Non-negative integers and non-negative rationals. Non-negative integers would be things like 0, 1, 2. Non-negative rationals would be positive decimals and fractions. So the question is it possible to go 2.3 miles? Or can you only go 2 miles or 3 miles and nothing in between? Hopefully you realize you can drive a part of a mile. So number 4 is going to be our answer. 8. Which value is equivalent to the product of 4 radical 2? Product means multiply. So I am multiplying 4 times radical 2 times 2 times radical 6. I'm going to multiply what's outside the radical, so that becomes 8. And then I'm going to multiply what's under the radical, that becomes 12. So 8 radical 12. That's not one of my answers, which means this must be reduced. 12 breaks into 2 and 6, and 6 breaks into 2 and 3. Remember our little shortcut. If you have an identical twin, you can leave the house. So 2 has an identical twin, so 2 gets to leave the house being the radical. And 3 is going to stay under the radical. So 2 times 8 is 16, and then what's left under the radical is 3. So my answer choice is 1. There is a way to check this in the calculator. If you add a calculator page, you can type in 4 radical 2 times 2 radical 6. And if you hit enter, you get a long decimal. That is irrational, the result of that. And then you can type in your answer choice, 16 radical 3. And if I hit enter, I can see those are equivalent. So I can feel confident that I got the right answer. If they wanted you to add, they would have asked you about the sum. The sum means add. Difference means subtract. And quotient means divide. Those are good things to commit to your memory. Number 9, the zeros of this function are. Remember we said when you see a function rule, graph it. So I'm going to go ahead and graph this and just see if it's helpful. So in my graph, I've got 2x to the third plus 12x minus 10x squared. So if I hit enter, they want to know the zeros of this function. Well, the zeros are where it hits the x-axis. So if I go to menu, trace, graph trace, and I start to trace, I see my first 0 is at 0. Remember, zeros are the x values. So my first 0 is at 0. I can keep going over. There's my second 0 is at 2. And I can keep tracing. There's my third 0 is at 3. Whoops. So that's answer choice 3. Now, what if this were not multiple choice? How would we do this? Well, to find the zeros, you take your function 2x to the third plus 12x minus 10x squared, and you set it equal to 0. The only way I can solve this is by factoring because it's not a quadratic. The degree is 3. So I have to factor this. And remember, when you factor, you must check for a GCF first. I can take a 2x out of all of these terms. So I'm going to divide all of these terms by 2x. As a quick reminder, this first term, 2x to the third, means 2 times x times x times x. And I'm dividing it by 2x. So these 2's divide out and one of the x's divides out. So that leaves me with x squared plus my second term is going to leave me with 6 minus, and then my third term is going to leave me with 5x. Carry down your equal 0. I notice that this is not in standard form. So I'm going to go ahead and rewrite it in standard form. And now I can factor this. And that is a trinomial. So I'm going to have to try hard to factor it. So I'm looking for things that multiply to 6x squared, add to -5. So 1x and 6x, but that adds to 7. 2x and 3x, that adds to 5, but not negative 5. So if the number is right, but the sign is wrong, change the signs. Whoops. And remember, a negative times a negative is a positive when you multiply. And negative 2 x's plus negative 3 x's will give me the negative 5 x's I need in the middle. So if I continue to factor this, I can't forget my GCF. And then that trinomial factors into x minus 2 times x minus 3 equals 0. Remember, your factor, t-chart, solve. So now I set up my t-chart. And I set each of those factors equal to 0. In this first equation, I would divide both sides by 2. That'll give me x equals 0. That's my first root, or 0. Add 2 to both sides. My second 0 is x equals 2. Add 3 to both sides. My third 0 is x equals 3. And that matches answer choice 3. Okay, number 10. How many of the equations listed below represent the line passing through the points 2, 3, and 4, negative 7? Well, how can I easily tell if a line goes through points? I can graph it. So I'm going to add a graphs page. Now, in this top equation, y is not alone, which means I have to graph it as a relation. So I'm going to type in 5x plus y equals 13. And now if I go menu, trace, graph trace, I can type in my first x coordinate, which is 2, and I can see it goes through the point 2, 3. And then I can type in 4 and see it goes through 4, negative 7. So the first one works. If I hit tab, I can put in my second one. So y plus 7 equals negative 5, parentheses, x minus 4. Enter. Oh, wait a minute. That's the exact same line. So if the first line passed through those points, this one is equivalent. So it does as well. Okay, let me do the next one. Y equals negative 5x plus 13. Oh, wait a minute. That's equivalent. So this also passes through those points. And then my last one is y minus 7 equals 5 times x minus 4. Oh, wait a minute. That is not the same line. And if I go to menu, trace, graph trace, and if I hit my up arrow till I get to relation 4, I can type in 2 and hit enter, and I can see it goes through 2, negative 3, not 2, 3. So it looks like this last one won't work. So how many of them pass through those points? 3 of them do. Okay, 11. The graph below models the cost of renting video games with a membership in Plan A and Plan B. Write equations to represent Plan A and Plan B. Show your work. Remember, you can never go wrong setting up a table. So for Plan A, I've got X and I've got Y. I know when X is 0, Plan A is here at, let's see. It looks like we're probably counting 5, 10, 15, 20 by 5s. So it's 0, 25. Then I've got to find another good point on Plan A. And it looks like my next good point is right here. 2, 4, 6, 8, 10. And then this would be 45. And then I could keep going. My next good point looks like it's here. So 16, 18, 20. And that is at 65. So now I can take a look and annotate my table. My X's are going up by 10 each time, and my Y's are going up by 20 each time. So when I go to write my equation, this line starts at 25 when X is 0. And I just need to figure out what I'm adding over and over. I need to be careful though. I'm adding 20 when X goes up by 10. So to figure out what I'm adding each time, I've got to find my slope. Change in Y is 20, change in X is 10, that's 2. So this would be 25 plus 2X. That's the equation for plan A. If you want to pause the video and try to make a table and equation for plan B, you can definitely do that. Plan B starts here at 0, 15. And then another good point I notice is right here. And that point is at 2, 20. The next good point is here. That's at 4, 25. So I know my equation for plan B is going to start at 15. I just need to figure out what I'm adding. Well, when X goes up by 2, Y goes up by 5. So if I do change in Y over change in X, I get 5 over 2. And then if I use my calculator, comes out to be 2.5. So here's my equation for plan A. Here's my equation for plan B. Explain why plan B is the better choice for Dylan if he only has $50 to spend on video games. So if Dylan has $50, okay, if I look at my graph, here's $50. So in plan A, he can buy about this many video games. In plan B, he can buy about this many video games. So it looks like in plan B, he can buy more video games for $50 than he can for plan A. The other way you can do this is using your equation. So for plan A, my equation is Y equals 25 plus 2X. I'm going to put 50 in for my Y value. And I'm going to solve for X. And then I'm running out of room, so I'm going to go over here. And I get 12.5 is the number of games he can get for $50 on plan A. For plan B, my equation is 15 plus 2.5x. I'm going to put 50 in for the Y value because that's the price. And I'm going to go ahead and solve. So I get 35 equals 2.5x. And I'm going to divide both sides by 2.5. So 35 divided by 2.5 is 14. So why is B a better choice? Plan B is a better choice because he can buy more games for $50 than he can with plan A. The next thing, Bobby wants to spend $65 on video games, including the membership fee. Which plan should he choose? Well, let's look at where 65 is. $65, whoops, is right here. And if I go out, that's where these intersect. So which plan is a better choice? either for $65, both plans allow you to rent how many games? Let's see. 20 games. So one is not better than the other. The plans are exactly the same if he has exactly $65. Last one. An Air Force pilot is flying at a cruising altitude of 9,000 feet and is forced to eject from her aircraft. Here's the function that models the height in feet of the pilot above the ground, where T is the time in seconds after she is ejected. Determine and state the vertex of h of x. So the first thing I'm going to do is I'm going to graph this. I've got negative 16x squared plus 128x plus 9,000. Now, when I hit enter, nothing shows up. But if I go to menu, trace, graph trace, you'll notice that at 0, I get out here. Now, don't worry so much about that 9e plus 3. What I'm going to do is I'm going to start hitting my over arrow to see if I can find the vertex. And there it is. Okay. Now, again, it's giving me my answer in this weird form. 4 comma, something with an E in it. So another way I can see points on a graph is by hitting Control T to look at a table. Because I know my vertex is at 4, I can see that that Y value for my vertex is 9,256. So determine and state the vertex. I did that. Explain what the second coordinate of the vertex represents. The second coordinate is this number right here. 9,256 is, and the important thing is, what's significant about the vertex? It's the maximum height. The pilot reaches. That maximum is a key. After the pilot was ejected, what is the maximum number of feet she was above the aircraft's cruising altitude? When I go back and read, I see the cruising altitude is 9,000 feet. So the maximum number of feet she was at was 9,256. How far above 9,000 was that? Well, I have to subtract those, and I get 256 feet. It says justify, not explain. This calculation right here is a sufficient justification. Okay, and that's it for this review.